Hello and welcome to this video by Medic Mind. My name's George and today I'm going to be running through the BMAT paper 2 of 2020. We'll be covering all of the questions and I'll try and help you with some tips and tricks that I like to use myself. Okay, so here we have question 1 of section 2 of the BMAT 2020 and it's a biology question, which is fairly nice to start us off. We've got a list of 4 statements and we're asked which pairs of these statements are correct. If we take them one by one, we can see that statement 1 is all about asexual reproduction and whether it produces genetic variation. Hopefully you know from your studies that asexual reproduction produces the least amount of genetic variation, and actually the idea that this always produces genetic variation is wrong. So we can go ahead and mark that incorrect. We can then look at statement number 2. Gamete production is the only possible source of genetic variation in sexual reproduction. Again, this one is false. Actually, in sexual reproduction, you can have mutations happening in the DNA, which then create genetic variation not associated with the initial production of the gametes. So statement number 2 is also incorrect. If we look at statement number 3, the environment can cause genetic variation. Well, this seems to make sense. If you went and exposed yourself to many UV radiation rays, or you went into a big X-ray machine and sat there for 2 years, you would expect to have some mutations in your cells and as a result, genetic variation in those cells. Therefore, the environment can lead to genetic variation. And finally, mutations can produce genetic variation. Absolutely, this is one of the major drivers of evolution, and so this one is correct, and it's important that you remember that. So looking through our answers, we can see that 3 and 4 are correct, and therefore the answer to this one is F. Moving on to the second question of this paper, and you can see that it's more physicsy, which may be a bit more challenging. The question is asking us to calculate the relative atomic mass of this element from its 2 isotopes. Hopefully you know that the relative atomic mass is essentially a weighted average between the masses of its isotopes, weighted by their sort of prevalence in the environment. In this case, we have to first employ our knowledge of what is the relative isotopic mass of each of these isotopes. You can see in isotope 1's case, that's 69, in isotope 2, that's 71, and that's calculated from adding the number of protons to the number of neutrons. So I'm just going to write that down here. Now hopefully you can see from this, we now have to weight it by its abundance in the environment. So to calculate the relative atomic mass, we have to do 69 multiplied by 0.6, because it's 60%, plus 71 multiplied by 0.4. So I'm going to write that calculation down on the screen. Now, when you calculate this all through, you get the answer of 69.8, which matches with our answer of E. However, you didn't need to do all of that calculation, and if you were being smart with the BMAT and trying to save your time, you can start to eliminate some answers straight off the bat. For example, we can clearly see that both of the relative isotopic masses are quite close to 70. Therefore, the idea that the relative atomic mass would be down at 31, 38.8 or 39 clearly seems a bit far-fetched. It's unlikely to be A, B or C, so we can cross those off straight away. Now looking at D, E and F, you can see that the answer should be between 69 and 71. Ideally, it should be a bit weighted towards the 69 element because that's more prevalent in the environment. So therefore, it should be below 70. That means that we can exclude answer F from the answer. And if you look at answer D, 62 again seems a bit far away and is not between 69 and 71. So all in all, you could just basically do it by intuition and focus on answer E from the get-go. Hopefully that was helpful, and that's a really good tip and trick that I would give for any question in the BMAT. Try and eliminate the answers first and look to see which calculations are really necessary. Now let's look at question 3. And this is again a physics or chemistry style of question, which is all about the sort of temperature gradients, if you like, between different locations. We can see that we're discussing a large open-topped freezer and the reason why the contents remain frozen even when it is open-topped. Now, the basic idea behind this is that colder air is a bit more dense, and that's because the particles don't have as much thermal energy and therefore are a bit closer together, a bit more packed in, and that essentially increases their density. If I draw a little diagram, a hot situation, the air molecules might be a bit like this, where in a cold situation, the air molecules might be buzzing around a little bit more closer to each other. As a result, you can clearly see that the bottom one in blue, the colder air, would be a bit more dense, and so therefore would tend to lie below the hotter air. If we look at the answer options, the only one that fits that is answer option D. So our correct answer here is the cold air in the freezer is denser than the hot air above the freezer, and that means that the contents lying below the hot air will not be warmed up. Instead, the cold air will stay dense, it will stay around those frozen products, and the warm air will simply rise to the top and escape the freezer. So the correct answer here was D. Now let's move on to a more mathematical question, and these ones tend to be a bit more straightforward and just rely on very good mathematical reasoning. You can see here we've got an equation, 2 minus this expression, and instantly you should try and work out whether that bottom part of the denominator can be factorized. We have a squared value, and therefore we should start to think about whether we can take out a factor, in this case it would be useful, of 2x plus 1. So let's do that. We can rewrite this, 2 minus 2x plus 1 over 2x plus 1 squared. Now, if you couldn't initially spot that, the things that I used to sort of pick that out, if you like, is because we've got 4x squared. So instantly the one that should be coming to the top of your head is, could this be 2x and then all of that squared? And as well, this isn't a sort of difference of two squares. You can see we've got a term in the middle there, the 4x, which is telling us that this isn't the difference of two squares. So we can simply write it 2x plus 1 squared, and feel free to expand that and see that they're identical. Now, having done that, we can eliminate 2x plus 1 from either side. So we can cross off one of these and then leave us with one lot of 2x plus 1 on the bottom. If I rewrite that, hopefully you can see this situation is correct. Now, we can now look at the answer options and see what roughly we're trying to get to. You can see that none of them have that 2 minus at the front. So therefore, it would be wise to try and turn that 2 into a fraction, which we can then incorporate into the latter fraction. We can write that 2 as a situation of 4x plus 2 over 2x plus 1. That would essentially cancel out to give us our 2. So let's do that. You can see that the bit in green is identical to the number 2. And then we can finish off writing the rest of the equation. And once we have this equation, it's easy to see now how it simplifies. The 4x plus 2 can be combined with the numerator of minus 1 on the top, so we end up with a numerator of 4x plus 1. The denominator stays the same, so 2x plus 1. And you can see, looking at the answer options, we can see that fits with answer option A. And now we're back to biology again, which hopefully should be a bit more useful. Here is question 5, and it's a question about stem cells. We're given again 3 statements and asked to pick which one or which combination is correct. And it's particularly comparing stem cells from an embryo to stem cells derived from bone marrow. In other words, embryonic stem cells versus adult stem cells. If we take these statements one by one. Statement number 1, both of these stem cells can divide producing daughter cells. That would be correct. But each daughter cell will contain one haploid copy of the donor's genome. That bit about the haploid is the problem here. In fact, they would contain a diploid copy of the donor's genome because the cell has identically replicated itself. Haploid essentially means that it has half the amount of genetic information, and you should remember that only gametes are haploid. So 1 is incorrect. If we look at statement number 2, the stem cells collected from an embryo are able to differentiate into a wider variety of specialized cells than adult bone marrow stem cells. That is absolutely the case. A cell within the embryo can develop into any cell in the body. If you think about it, it has to in order to make who you are. In comparison, a bone marrow stem cell can only really replicate itself and then produce its constituent blood products. It's not going to be able to differentiate into nervous system tissue, for example, at least without any outside help. So in that case, number 2 is correct. The wider variety of cells that can be derived from the embryonic stem cell compared to the adult bone marrow stem cell. And finally, number 3, the use of stem cell therapy to treat a medical condition can increase the risk of a person developing cancer. At this point, it's worth remembering what cancer is. It's an uncontrolled replication of cells. Therefore, it's easy to see that if you inject someone with a set of stem cells, if those stem cells continue to divide, we may end up with a cancer on our hands. So all in all, 2 and 3 are correct, and that means the answer to this one is G. Back to chemistry then, and we're on question 6 of our 27 of the BMAT 2020 section 2 paper. This question is all about oxidation states and which elements are being oxidized or which elements are being reduced and how their oxidation numbers are changing. We can see that this reaction is here in front of us, and it should already flag up in your mind that this could be a disproportionation reaction. It's an unusual reaction, one that we wouldn't typically see, and therefore maybe there's a reason why it's been put in front of us. So already we can probably lean towards statement number 2 being correct. If we look at statement number 1 first though, chlorine has an oxidation state of +5 in this NaClO3 compound. We can take this one by one. The oxygen has an oxidation state of -2. The sodium has an oxidation state of +1. As a result, when we add up 3 lots of the oxygen, we end up with a state of -6 overall, plus the +1 from the sodium, that takes us down to -5. So therefore we need a chlorine of +5 in order to balance that out and mean that the overall oxidation state is 0. So absolutely 1 is correct. Chlorine does have an oxidation state of +5 in order to make that whole compound 0 overall. If we look at number 2, we can see that this is also correct. Chlorine, in the first instance here, on the left of the reaction, has an oxidation state of 0. It's in its elemental form. If we compare that to on the right, we can see in the sodium chloride, the chlorine has an oxidation state of -1. That is because the sodium has +1, the chlorine has -1 to make it 0 overall. By comparison, in the NaClO3, we've already shown that it has a +5 oxidation state. That tells us that the chlorine has both simultaneously been oxidized as well as reduced. So this is a disproportionation reaction because that's the definition, a single element being both oxidized and reduced in a reaction. And finally, looking at statement 3, some of the oxygen in the hydroxide ions is oxidized. That would imply that the oxidation number has gone up. Now, in the hydroxide ions, the oxygen has an oxidation state of -2. In fact, in many reactions, in many situations, oxygen always kind of gets priority on that -2 oxidation state. And that's the same in the NaClO3 compound as well as H2O. So its oxidation state hasn't changed, therefore oxygen has not been oxidized or reduced. So 3 is incorrect. Overall, that tells us that 1 and 2 are correct, so the answer to this one is E. Well done for getting that one right. It is a more complicated chemical reaction. Now let's move on to a question about electricity, and this one is all about circuits, in particular how the qualities of series and parallel circuits differ in terms of current, voltage and resistance. You should know from your own GCSE knowledge and potentially a bit further reading that in a parallel circuit, each branch of the circuit receives the same amount of voltage, that is, the same voltage as the power supply. So we can already see that statement number 2, the voltage across the heating element will be 240 volts, is correct. Because once that switch is closed, the circuit is behaving like a parallel circuit, and that branch of the circuit will receive the same voltage as the power supply, just like the motor will receive the same voltage as the power supply. Now, with regards to the overall resistance of the circuit, you should be able to realize that the series and parallel circuits are different in terms of how they treat resistance. In a series circuit, the resistance is additive. You add an extra component, you just add on the extra resistance. In a parallel circuit, it's a bit more complicated if you add on extra branches. I'm going to write down the equation for the total resistance of a parallel circuit. Here you can see that the total resistance of this entire circuit, 1 over RT, is the inverse, and it's equal to 1 over the resistance in branch number A, plus 1 divided by the resistance in branch number B, and if there was another branch, it would be plus 1 divided by the resistance in branch number C. So the resistance is treated slightly differently in parallel circuits. So when we appreciate statement number 3, the resistance of the circuit is smaller than when it is with the switch open. That is absolutely correct, because now we've given an alternative route through which electrons can flow. We've given them a bit of more of an option, if you like, and therefore the resistance should be less, and you can see that from the equation, because these will all be inverses. Now, because the resistance is less, we therefore start to play with how much current is going through this circuit. And that means that far from the 0.4, the current will actually be overall different anyway, regardless of the branches that we've added. So even though you may think, oh, it makes sense, the motor had 0.4 amperes beforehand, now we've closed the switch, it should be split between the two elements because current is split across branches. Because we've changed the overall resistance of the circuit but kept the same voltage, the overall current will change in accordance to Ohm's law. It doesn't matter what that current is, all we know is that it has changed. So even though you are absolutely correct that each branch of the circuit will have a current which adds up to the total amount of current in the circuit, that total amount of current has changed. So 1 is not correct, whereas 2 and 3 are. So for this question, answer option G is correct. Now let's look at this question, and this one's fairly straightforward, so we won't take too long on it. We know that the sale price of a camera is 180, but that's been discounted 20. So we can start to set up an equation. We know that the price originally of the camera was X. It's been discounted 20%, so that's the same as multiplying by 0.8, and that should be equal to 180. We can simply then take over the 0.8 to the other side, and we end up with an expression of 180 divided by 0.8 is the same as X. So the answer to this one is D. Okay, here we have a biology question. It's all about inheritance and alleles, which is a staple question of the BMAT, so make sure you're familiar with it. We can start by labeling the alleles whatever we like, and I would recommend labeling them with distinguishing letters where the capital letter is different from the lowercase letter. In this case, let's choose big R and little r. We can see that a homozygous dominant rabbit, big R, is crossed with a rabbit that did not have the condition. In other words, a homozygous recessive rabbit. From this crossing, you can see that the offspring can only inherit the big allele from the one with the condition and the little allele from the one that didn't have the condition. So all offspring, all 3 of them, must be heterozygotes. We then take one of these rabbits, let's say this one, and cross it with another rabbit which has not got the condition. In other words, it's another homozygous recessive rabbit. Now we know that out of this crossing, we get 3 offspring, 2 of which have the condition, so they must be heterozygotes, and 1 which does not, so that must be a homozygous recessive. So you can see here we've got the different generations of all of the rabbits, ignoring this one which isn't part of the family. If we focus on all of these generations, we then just have to add up the number of copies of the allele in each situation. Now it's worth considering what exactly is interphase. Interphase is the stage between mitotic events, and therefore there should only be these alleles in each cell. It's worth considering because if you were entering mitosis, you might already have duplication of alleles within the same cell. In this case, we don't have to worry about that complexity. So all we need to do is add up the total number of copies of alleles for this condition. We can see we have 1, 2, 3, 4, 5, 6, and 7. So the answer to this one is B, and that's 7. Here we have a reaction and a reaction energy diagram. So this fits into chemistry. Essentially, the skill with this question is just to understand the diagram, and hopefully you've come across these before in your studies. We can see here that this is a reaction in which there is an exothermic loss of energy. Now, the question asks us what happens when we do the reverse, when we change 1 mole of ammonia, decompose it into its constituent elements. So essentially, we're doing the opposite reaction. That means that the overall energy change will be the opposite sign to this, so it would be plus 92. But remember here we had 2 moles of ammonia, we're interested in 1 mole of ammonia. So overall, it will be half of this value and flip the sign. So the answer should be 46, and that will be absorbed because the reactants, the NH3, are a lower energy level than the products will be. So energy must have been absorbed, and it's 56 kilojoules of energy. So the answer to this one is A. Here we have a maths question about a gold medal in the Olympics, which is very topical for 2020 and 2021 with the Tokyo Olympics. Now, a gold medal, we're told, weighs different amounts of things depending on the mass of the medal and how much mass is the coating. We're then given the density and we're expected to work with these numbers in order to calculate the volume. So it's a straightforward density, volume, mass question and rearrangement of that equation. The first thing to do is to split up the 256 into its constituent parts, that is the metal and its coating. We can see that the coating weighs 24, and therefore, by definition, the 256 minus 24 will give us 232. And these are both in grams. Once we've got the weight of different things, we can then start to bring in the density. We know that the silver-nickel alloy used to make the actual medal is 10 grams per centimetre cubed. So we can do this 232 and divide it by 10. And that gives us a nice answer of 23.2 centimetres cubed. We can do the same thing for the coating. So we've got 24 grams. It has a density of 16 grams per centimetre cubed. So we simply divide it by 16. And hopefully you recognise these are both multiples of 8. So you can fit in 1 lot of 16 and a half into 24. So overall, this is 1.5 centimetres cubed. If we then add these two together, we will get our answer. In this case, it's 24.7, which gives us answer option D. Now let's tackle this maths question, which is a bit more challenging. It has a circle, so we might be expected to work with some circle theorems. We're told some information about the layout and the fact that it's got an equilateral triangle within it, and we're asked to calculate what is the radius of the circle. It's a bit complicated because you might be able to do it different ways and you have to kind of fit yourself into a box as to what the answer options are wanting. Now, looking at the answer options, we've got a lot of sine, we've got a lot of cos, we've got a lot of tan. It doesn't really offer us too much advice on which one to use or which one to try and aim to get. So therefore, let's just start where we start and see where we go. We can look at the answer angles being 60. We know that this is an equilateral triangle, so all of these angles will be 60. We can then use our circle theorems to draw a second triangle that looks something a bit like this. And this angle here from our circle theorems will be double the one in blue. That is, it will be 120. But we're not really interested in that angle. We're actually interested in its half here. And you can see that because the whole angle was 120, half of this angle will be 60. Just like it was in blue. You can see that the side length of this little triangle that we've got is going to be 5 up here, and the radius on the hypotenuse is r. Hopefully you can see that our triangle is already looking a bit like we can do trigonometry. So I'm going to take it out of the circle and draw it in full so you can see which one to use. Hopefully you can see from this that we've got the opposite and the hypotenuse, so we should be using sine. We know that sine 60 should therefore be equal to the opposite divided by the hypotenuse. Rearranging this equation, we get r is equal to 5 divided by sine 60. All in all, that gives us answer option D. So fairly straightforward trigonometry, complicated a little bit by spotting the right circle theorem to use. So with this answer, I would really try and use all the skills in your toolbox, try and look at those circle theorems, see what you can do, and try and create your own right-angled triangles, because that's the way that you advance these questions, by drawing on the diagram and seeing what extra triangles you can come up with to help you answer the questions. Okay, now we're looking at a question which perhaps falls on the borderline of chemistry and biology. We've got different processes and whether they add carbon dioxide, remove carbon dioxide, add oxygen or remove oxygen. It's quite overwhelming the amount of different combinations that we have, so we have to simplify our job. My advice would be to focus on this adds oxygen column. That's because you should know that there are very few processes which actually add oxygen to the environment. Particularly when you look at the types of things that we've got in this table. We've got combustion, we've got decomposition, we've got respiration, we've got photosynthesis. Out of that kind of brief scan, only really photosynthesis is adding any oxygen. So this will help us narrow down our answer options quite quickly. Looking at this adding oxygen column, the only two that are relevant are A and D, because only photosynthesis is adding oxygen to our environment. Now looking at A and D in particular, we can then start to look at different things. You should also be aware that removing carbon dioxide is quite a rare task in biology. Most living things probably add carbon dioxide to their environment, so that should be a column that we focus on second. Comparing A, which has aerobic respiration, which we know produces carbon dioxide, and D, looking at photosynthesis, which we do know removes carbon dioxide, we can instantly cross off A from our answer options, and we're left with D. So that's the correct answer here. We didn't even have to use the first or the last column. We can zoom straight to our answer of D. As a recap, we did that by elimination, focusing on the adding oxygen and removal of carbon dioxide, which are rare biological events. Now we have a chemistry question, looking at four metals and deciding whether they are more reactive or less reactive than each other. And we can take it step by step. R fizzes when added to dilute hydrochloric acid. That's a standard reaction of a metal. The bubbles that are created are hydrogen gas. Then we get T is precipitated when R reacts with an aqueous solution of compound T. That's a displacement reaction, and it's telling us that T is therefore less reactive than R because it's being displaced by R when R is reacted with it. So we know already that R is ahead of T. So let's write that down. Now looking at X, X is one of the metals that occurs naturally in Earth and it is uncombined with other elements. In other words, it is so unreactive that it doesn't really like combining or sharing its electrons with anything else. So therefore we know from the get-go that X is a very unreactive element, something like gold or silver. So we can put X at the very bottom of our list in terms of least reactive. And finally, we know that Z is the only one of these metals that can be manufactured by electrolysis of its molten compounds and not being displaced by carbon. Therefore, that tells us that Z is more reactive than R and T because remember, electrolysis is only used when you can't really do this thing of heating the oxide with carbon because carbon is essentially less reactive than Z and therefore Z will stay at its compound if it tries to do a displacement reaction. Instead, you need the electrolysis process to really chemically split that compound apart. So Z is the most reactive of all of our elements here. Looking at this list and layout, we can therefore see that the answer option should be answer option F, Z, R, T, and X. Here we've got a physics question, and it's about radioactive decay, which again is one of those hot topics which you should revise and you should get familiar with, because a lot of the BMAT questions year on year like to bring this into play. Particularly about alpha versus beta decay, which is this question all over. The question gives us this element, thorium-232, and says that it undergoes a sequence of decays, 4 alpha and 2 beta decays. And we're asked to sort of assess what is the symbol for this nuclide that is produced. Now we can break this down. Remember that alpha particles contain 2 neutrons and 2 protons, whereas beta particles are essentially a fast-moving electron which has been sort of give rise to a proton. So essentially, while alpha particles are taking things away, beta decays sort of add an extra proton, if you like, and it does that from a neutron. So if we start to weigh things up, we've got 4 alpha and 2 beta decays. The 4 alpha decays, each with 2 protons and 2 neutrons, will reduce our overall mass number by 16. That is 2 times 2 times 4. Minus 16 to the mass number. Our beta decays, however, are not going to change the mass number because a neutron is simply changing to a proton. It doesn't affect the overall mass. What it will change, though, is the proton number. Now, from the alpha decay, the overall change in the proton number, because each alpha particle contains 2 protons, was a loss of 4 times 2, which is 8. The beta reactions, however, the 2 beta decays, will add back 2 protons because a neutron will decay into a proton. However, the mass number remains unchanged. Looking at the totals, we can see that the overall mass will reduce by minus 16, but the proton number will only reduce by 6. We then simply factor these numbers into these numbers up here, and we get 232 minus 16. That should leave us with an answer of 216. And then the proton number, we've got 90 minus 6, which is 84. So the answer here is C. Okay, on to the maths again. This case, we've got several different functions which are plotting different graphs, and we're asked which ones do not intersect. Now, you might be tempted to go away and try to set up some complex simultaneous equations with this one. What I would remind you of is your probable GCSE maths advice is to draw it. So absolutely get drawing this graph. Here's our set of axes. They're rather crudely drawn. Forgive my drawing. We can see that equation number 1 has a gradient of 2 and an y-intersect of minus 1. So let's plot that one in green. Doesn't really matter at this stage what the gradient is, but we may have to think about it going forward. Graph number 2, I'm just going to color code it. Graph number 2 is 1 minus x squared. So let's do that in blue. It's got an intersect of the y-axis of 1, and it's a minus x squared graph. So it's going to look a little bit like this, crossing at 1. You can already see that these guys intersect. Looking at graph number 3, we've got 1 minus x all squared. Now you may not know off the top of your head what this one is, but if you imagine expanding out those brackets, that minus x being squared is going to eliminate the minus. So this is an upright x squared graph with an intersect of 1, but a bit more complicated because it's also going to have an x term within it. We can also work out what intersect it will have with the x-axis, because when y is 0, it's clearly that x must be equal to 1, because then we would have 1 minus 1 is 0, all of that squared will be 0. So this graph, if we do it in pink, will cross the y-axis at 1 and the x-axis at 1 and will be upright. And finally, graph number 4, y equals 2 minus x. Clearly this is a bit more straightforward. It starts at y-intercept of 2, it then declines with a slightly shallower gradient to that of graph number 1 in the negative direction. So it starts up here at number 2, and it's going to go quite shallow downwards. Hopefully from this very crude little diagram, you can see immediately which ones don't intersect. You can see it's the blue line and the yellow line. So the answer to this one is 2 and 4, that is answer option E. And if you needed to, you could do a bit more complicated comparison using algebra, but in this case you can clearly see spatially they don't overlap. Let's look at question 17. Here we've got different tubes as well as an enzyme in different tubes, and it's asking us which one gives us amino acids. Now amino acids come from proteins, so we need a protease enzyme in there. Already we can therefore eliminate answer options, sort of test tubes 1 and 2 if you like. Looking at 3, 4 and 5 and 6, we can see that there's different things that are being boiled. In number 4, it's a boiled protease, which you should realise will denature the enzyme. So 4 isn't going to give us an active protease, so won't give us the amino acids we need. Looking at 3, 5 and 6, clearly the protease and protein option of test tube number 6 is a good thing. In terms of number 5, it doesn't matter whether the protein itself is boiled or not, so long as the protease is still active, so the amino acids will still be produced. And finally, test tube number 3, a protease and a lipase. Remember that an enzyme is a protein, so a protease acting on a protein like lipase will always give us amino acids. So the answer here is test tubes 3, 5 and 6. That is answer option F. Now let's look at this polymerization reaction. It's all about propene, and we're given a structural 3D format of this molecule. This should be a skill that you're readily familiar with, opening up that double bond and creating a polymer. Let's write it down. You can see here that we've got the CH3 group on the end. Then we've got a carbon atom correlating to this middle carbon atom. And then we've got a double bond to another C, filled it in with different hydrogen atoms. This is the same molecule as the one that they've shown you, just in a slightly easier format to see. When polymerization happens, that double bond in the middle is going to open up. And each carbon will gain an extra bond on each side. We then surround this in brackets. And instead of having n number of molecules, we now have an n beside it like this, because they're all joined together in a single molecule. Which one does this fit with? Well, you can hopefully clearly see that the answer is D. The reason that CH3 group remains separate is because that has nothing to do with the double bond. And remember, the double bond opening up is what's causing things to join together. This is a physics question, all about kinetic energy as well as speed. So we're going to be using our different sort of kinetic energy calculations and equations. We know that kinetic energy, if I call it K, is equal to half mass times velocity squared. By comparison, gravitational potential energy, which I'm going to call G, is the same as mass times the gravitational field times the height through which that object is raised. These are our two equations which we're going to be using in this equation. So we've got a mass of 45. It's been raised 10 meters above the ground and the gravitational field strength is 10. 45 times 10 times 10 gives us 4,500. That's its gravitational potential energy at the top. So when we drop it, just before it hits the water, as she hits the water, all of that energy will have gone into kinetic energy, and therefore the kinetic energy will also be 4,500. So we're looking at D, E, and F. Looking at D, E, and F, we now have to work out the speed. We know the kinetic energy is 4,500. We can then take this equation in blue and start to rearrange. We can do the 4,500 multiplied by 2 to get rid of the half. That will give us 9,000. We then have to take the mass onto the other side. So 9,000 divided by the mass, which is 45, will give us an answer of 200. And that's equal to velocity squared. Therefore, velocity is equal to the square root of 200. And we can take out the surd of 100 if you like, and this is the same as 10 root 2. So the answer here is E. Again, we're faced with a graph question, and as always, it's worth writing things down, drawing on the diagram as much as you can. We're told that PQRS is a kite. That means that roughly S should be lying somewhere along this line that I'm tracing out right now. We're told that the PS, so P to wherever S is, we don't know where it is a segment of the line 2y plus x equals 2. So, how do we go about working this out? Well, first we need to come up with a bit of an equation which we can then use simultaneous equations on with our PS information. We can work out the midpoint of PR. And that midpoint should lie on this line through which S lies. We would then have a midpoint here and the point Q, both of which lie on the equation which determines where the line is. And therefore we can work out the equation where S is sitting. We can then set that equal to and use the equation of PS to work out the precise intersection point which we're worried about. So let's start with the PR midpoint. The midpoint of 4 and 0 is 2. The midpoint of 5 and 1 is 3. The coordinates for Q now, if we forget that midpoint for just a second and look at Q, clearly it has the same x coordinate as P, that is 0, and the same y coordinate as R, that is 5. We can then set up an equation for a line that connects these 2 points together. We do change of y, which is 5 minus 3, that's 2. Over the change in x, which is 0 minus 2, that's minus 2, to get us an overall gradient of minus 1. We know that it crosses the y-axis at 5, so our equation is y equals minus x plus 5. We can then look at this equation down here and start to play with that a little bit, comparing it to this equation that we just got. We can double this equation first of all in order to allow us to start to use this 2y. Let's do that now. We can also rearrange this equation down here in order to get us 2y on its own. Setting these two as equal to each other now, we can start to work out the precise coordinates of the point S. Rearranging, we take the x onto the one side and we take the 2 over to the other side. 10 minus 2 is 8. So we know that the L coordinate is 8. We then can plug that into either equation to try and work out what y is. We know that y is the same as 2 minus x. 2 minus x is minus 6. Therefore, 2y is equal to minus 6. Y therefore must be equal to minus 3. But we're not done there. The question asks us for 2L plus M. We know that the x coordinate is the L, so 2 times 8 is 16, plus the y coordinate, 16 minus 3 is 13. So that's our answer. Now we're looking at food chains, and this is a biology question. We've got a rosebush, an aphid, and a ladybird. And we're asked to compare the sort of energy transfer between the rosebush and the secondary consumer, in this case the ladybird. We can see that the biomass per organism at each stage is calculated by the biomass total divided by the number of organisms in that level. So for the rosebush, 800 divided by 1, that rosebush itself has 800. And the units are arbitrary. For the ladybirds, we've got 10 biomass units divided by 50 organisms. That's the same as 0.2. So essentially the calculation that we're doing now is 0.2 as a fraction of 800 to work out the percentage energy transfer. Now you may not initially know how to calculate this in your head, but I will remind you that 0.2, if you multiply it by 5, will get you a nice round 1. So do the same with the denominator. 800 multiplied by 5 is 4,000. These two fractions are the same. Now that helps us because 1 over 4,000, even though it has plenty of zeros in, surely it will also have a 2 and a 5. 1 over 4 is 0.25. 100 divided by 4 is 25. It will have a 2 and a 5 in it. So we're looking at answer options A or F. And clearly F is way too high, so therefore we can pick A without looking at a calculator. If you wanted to work this one out exactly, you could absolutely do so. It might just take a little bit more time. So I prefer to work out the 1 and the 4, recognize that that's 2.5 or 0.25 or 0.025, and then kind of pick the magnitude of answer which makes sense. Now question 22 is a question about intermolecular forces. We're talking about some strange compounds, bromine chloride and bromine iodide, and we're asked that they melt at different points in time, at different temperatures. We're asked what is the best explanation of this. Now, these are covalent compounds. You'll remember that the melting and boiling points of covalent compounds are determined by their intermolecular forces, not the covalent bond itself. So already we can exclude A and B because they're talking about the covalent bonds. C, the forces between bromine iodide molecules are stronger than forces between bromine chloride, therefore makes the most sense. As for differences in the sizes of these ions, for example, well, we're not really talking about ions, we're talking about covalent compounds, so the ions is really irrelevant. If we then talk about the atoms themselves, arguably they don't form these giant covalent lattices, or at least we're not really interested in the sizes of these atoms. It's more about the intermolecular forces per se. So the answer option here that is correct is C. Now let's look at this example, which is from physics. It uses an equation linking wave speed, frequency, and wavelength. You should know from your equations that the speed of a wave is equal to its frequency multiplied by its wavelength. In this case, we have the frequency and we could work out the speed, and we're asked what is the wavelength at the end of it all. The frequency we know is 6,000. The speed can be calculated from knowing that it travels 750 there and back in 1 second. That is to say that it's not a distance of 750, but a distance of 1,500, because it has to go there and back in that 1 second. So we're traveling at 1,500 meters per second. Now, simply rearranging this equation, we can take the 6,000 onto the other side, and we get an equation that says W is equal to 0.25. The units are whatever units we calculated the speed in. In this case, we use the 750 multiplied by 2 to get the 1,500 meters per second. So this wavelength is in meters. Looking then at the answer options, clearly the wavelength of the sound in seawater is 0.25 meters, in other words, 25 centimeters. Okay, now we move on to, again, another circle theorem-y kind of question. And this question is all about looking at this perimeter of the area. So essentially read it first, make sure you wrap your head around it before giving it a go. The first thing to realize is this O lies at the center of a much bigger circle. And whenever we have a big circle, we like to put on different radii. So let's connect things up a little bit like this. We can see that the yellow lines represent radii of the bigger circle. So let's label them R. Now, once we've got these radii, we could also remember our circle theorem that states whenever you connect a diameter of a circle like this to any point on the semicircle that is created from it, we end up with a right angle here. So let's plot that on. Using this, we can come up with an expression of D using Pythagoras' theorem. We can see that r squared plus r squared, that's the same as 2r squared, should be equal, using Pythagoras' theorem, to d squared. Taking the 2 onto the other side and square rooting, we can see that r is the same as square root of d squared divided by the square root of 2. Now we can start to simplify, and we can see that the square root of d squared is just d over root 2. Now that we've got this, we're at a little bit of a dead end, essentially. We need to have another moment of inspiration, if you like. Now we can see here that this bigger circle, actually this value p is part of its circumference. In fact, it's a quarter of the circumference. Because this is a right angle, 90 degrees, and 4 lots of 90 form 360, this little sort of area here is 1/4 of the much bigger circle that we can see. Overall, that means that if we can calculate the circumference of the bigger circle, we can work out the value p. So let's do that now using our expression for the radius. We know that the circumference is the same as the 2 times the radius, in other words, the diameter, multiplied by pi. This is an equation for the overall circumference of that big circle. We then have to divide it by 4 in order to get our value of p. So let's divide it by 4. Simplifying this down, the 2 cancels with the 4 on the bottom. And we get an equation like this. Now, we have to remember that we're not interested in p, we're interested in the overall perimeter of this shape. So when we look at the distance xy, that's d, we have to add that on. So we can add d here. Now, it's not really helpful looking at the answer options to have this 2 root 2 on the bottom, so we need to rationalize that denominator by multiplying top and bottom by root 2. So let's do that in this space over here. That's a pi symbol, apologies. And then 2 root 2 multiplied by 2 will give us 2 multiplied by 2, which is 4. Plus the d that we had from over here in pink. We then express d as a fraction over 4, so 4d over 4. We can then take and combine these fractions to give us d times pi times root 2 plus 4d. We then, because d is common to both of these, can take d out of the brackets, and we end up with d bracket 4 plus pi root 2 all over 4. And that fits with answer option D. Now we're nearing the end of the exam. We're into some of the more difficult questions, even though that's not officially how BMAT sort of structures its exams. We can see this is a difficult biology exam, a biology question about base pairing. We're given different quantities of adenine, thymine and guanine on strand 1. It makes sense to fill that in completely and work out cytosine as well. So on strand 1, we've got 30% A, 28T, 25G, and 17C in order to make that up to 100%. That means on strand 2, we must have 30T, 28A, because A and T pair together, 25C, and 17G. We can now start to look at some of the answer options. B. The probability of any base in strand 2 being guanine is 0.17. Well, absolutely. We know that 17% of the bases in strand 2 are guanine, so therefore it stands to reason that 0.17 is exactly the probability of getting guanine in strand 2. So number 1 is correct. 2. If P is guanine and R is cytosine, a mutation must have taken place. If we look at it a little bit more deeply, if P is guanine, that's on strand 1, the corresponding on strand 2 is this X here. So this X must have been cytosine. So when the new strand is formed, R must base pair with cytosine, so it must be guanine. Therefore, the fact that if R is cytosine and not guanine, then clearly a mutation must have taken place because we've got an error in the DNA code. So 2 is also true. And finally, statement number 3, the copying process is taking place during mitosis. This is incorrect. The copying process actually takes place before mitosis happens. So the answer to this one is E. Our penultimate question is a complex chemistry question, and it's all about calculating masses and moles. You should be fairly well equipped with this from your GCSE, however. We're even given the MR values to help speed up the process. We know that we have 3.4 kilograms of ammonia. We know that it has an MR value of 17. So the amount of moles that we have is 3.4 divided by 17. Now I'm not going to bother writing this repeatedly over and over again because I recognise that 3.4 does have something to do with 17. You can see that 17, 34, they're all part of the 17 times table, so this fraction here should cancel down quite nicely. And indeed it does. It's the same thing as 0.2 or 1/5. Now we've got 1/5, we now have to move over to find out how many moles of this we have, which should be half. We also have to remember that we've got a yield of 80%. So essentially, we're multiplying this by 4/5. Now the reason I've kept it in fractions and not decimals or percentages is because sometimes you can cancel things out. In this case, it's not particularly helpful, so by all means go ahead with decimals and percentages. But in this case, you've got 0.2 multiplied by 0.5 multiplied by 0.8 in order to calculate overall the amount of sort of moles that you've got of this compound here. But we're not asked the moles, we're asked what mass do we end up with. So we have to remember to multiply it by our MR, which is 132. When we do this, we can work out 132, we can take a half of it, that gives us 66. We can then divide that by 5, that gives us a total value of 13.2. And then finally, we can take 18% of that, 80% of that by dividing by 5 and multiplying by 4. So essentially, we don't really have to work it out too much because clearly we've got 13.2 here. We take 80% of that. It's not going to be as low as 5.28, so we end up with an answer of B. Okay, and on to our final question of this paper. So you'll be glad to know this is the end. This is a physics question, and it's all about a rotating bar magnet. We're told about what can increase the frequency of the sort of change in direction of the current, as well as the maximum voltage it creates. Statement 1 advises that we should increase the number of turns of the wire in order to increase the maximum value as well as the frequency of the induced voltage. Well, it will definitely increase the maximum value. However, it won't affect the frequency, which is more determined by this 120 revolutions per minute. So number 1 is incorrect. Number 2, looking at the direction of the induced voltage in the coil reversing, remember that the direction of the current reverses, the voltage reverses every half turn. Now, if we look at the 120 revolutions in 60 seconds, that's the same as 2 revolutions every 1 second, 1 revolution every 0.5 seconds, and 0.5 revolutions every 0.25 seconds. Essentially what we're saying is that the current is flipping because we're going through half revolutions every 0.25 seconds. Essentially, that means that number 2 is correct. And finally, number 3, there is always an induced current in a conductor which is experiencing a change in magnetic field. Now, that's not always the case. If we plot out what will be happening with the sort of current and the voltage, they'll be alternating like this. And clearly you can see that at some points in time, we're crossing the x-axis. In other words, the induced current can be 0, but it is a dynamic quality. So there isn't always an induced current when a sort of conductor is experiencing a change in a magnetic field. So 3 is incorrect. And all in all, that means that C is the correct answer here. Okay, I hope that was all useful. And I hope if you got those questions wrong, you can go over them with this video and work out the correct answers and how to do it in the best way. Thank you very much, and I'll see you next time.
So if you like this video, give it a thumbs up, leave a comment below, and share it with your friends so that they don't miss anything out on the journey into medical school. To unlock the rest of the series, which is 70 videos including live walkthroughs and over 1,000 different questions, just click the link in the description below.